Hello friends, myself Aher from RBNB College Srirampur. Today I deliver a lecture on mechanical properties of solids from 11th Science as per Maharashtra State Board. Now in case of mechanical properties of solids, we study about the stress. Now in this lecture we have to study about the strain. So for strain, remember the formula: change in a dimension upon original dimension. That is called as strain. So with the help of this formula, we can define the definition of strain. Strain is defined as a ratio of change in a dimension to the original dimension. In this, we consider change in the length, then change in the volume, and we consider change in the shape. So we can define the definition of strain is as like that. Strain is defined as the ratio of change in a dimension to original dimension. That is called as strain. As strain is ratio of similar quantities, therefore this strain is unitless and dimensionless. As like stress, again there are three types of strain. So we can classify the strain. So first type of strain, when deformation consists of change in the length, then such type of strain is called as tensile strain. Another type of strain is volume strain. When deformation consists of change in the volume, then corresponding strain is called as volume strain. And remaining third type of strain is shearing strain. In that case, when deformation consists of change in the shape, then corresponding strain is called as shearing strain. Now we have to concentrate on the tensile strain. As we know that in case of tensile strain, we consider change in the length. So for that purpose, if we consider a wire whose original length is small l, as like this one end of wire is connected to the rigid support, and another end of the wire is connected to the suitable mass. Due to that weight, wire get elongated through small distance. This distance is delta L, which is very small, and this is called as change in the length. Now we have to find out tensile strain. So for tensile strain, formula is change in length upon original length. That is called as tensile strain. So with the help of this formula, we can define the definition of tensile strain. Tensile strain is defined as ratio of change in the length to the original length. So with the help of this formula, we can define the definition of tensile strain. So we write definition of tensile strain. Tensile strain is defined as the change in a length per unit original length. It is called as tensile strain. In another word, we can say that tensile strain is simply ratio of change in the length to the original length. Also, this tensile strain can be defined as tensile strain is defined as the change in length per unit original length. Now we consider the diagram. Then tensile strain, it is also called as longitudinal strain, that is equal to, now in this case change in the length is given by delta L and original length of wire is small l. So we get tensile strain is equal to delta L upon L, where delta L is the change in the length and small l is the original length. And therefore we can say that in case of tensile strain, deformation depends upon change in the length, and when deformation consists of change in the length, corresponding strain is called as tensile strain. Now we have to study about volume strain. So formula for volume strain is change in a volume to original volume. So in this case, when deformation consists of change in the volume, then corresponding strain is called as volume strain, and that's why we write formula for volume strain is ratio of change in the volume to the original volume. So we define the volume strain is as like that. The volume strain is defined as ratio of change in a volume to the original volume, or in another word we can say that volume strain is defined as change in a volume per unit original volume. That is called as volume strain. So for that purpose we consider a volume of gas is enclosed in this balloon whose volume is V. Now when this balloon is pressed in all directions by a pressure of magnitude dP, then its volume goes on changing through small amount by dV. dV is the change in the volume. Now in that case, new volume will become V dash and original volume of balloon is V. So due to that pressure del dP, there is change in the volume which is given by dV. So according to formula of volume strain, we get volume strain equal to change in the volume. In this case, change in the volume is given by dV, which is very small, and original volume is given by V. So we get volume strain is equal to dV by V. So in case of volume strain, we can say that deformation consists of change in the volume, then corresponding strain is called as volume strain. Now we have to study about the shearing strain. In a shearing strain, we write formula for shearing strain is, it is ratio of relative displacement of any layer to its perpendicular distance from fixed layer. As you know that when deformation consists of change in the shape, then corresponding strain is called as shearing strain. It can be defined as ratio of relative displacement of any layer to its perpendicular distance from fixed layer. Now shearing strain can be studied with the help of cube. So here we consider cube A, B, C, D, E, F, G, H. As like this one. When we apply tangential force to the upper layer, then if you consider front side A, B, C, D for our understanding, we consider this front side A, B, C, D. And if we apply tangential force to the upper layer, which is given by F, then this A move towards A dash, but B remains as it is. Due to that tangential force, D move towards D dash, C remains as it is. It makes an angle theta. Similarly, this angle is also theta. So this dotted line shows the change in the shape of that cube, and that is called as shearing strain. So if we apply tangential force to the upper layer, then it moves shifted towards A, shift towards A dash, as like this one. E shift towards E dash. Similarly, F shifted towards F dash, and D shifted towards D dash, making same angle theta. And there is change in the shape of that body. That is called as deformation consists of change in the shape. Then strain is called as shearing strain. And as you know that shearing strain can be defined as a ratio of relative displacement of any layer to the perpendicular distance from fixed layer. If you consider this first front side, in that case relative displacement is given by A dash and perpendicular distance is shown by AB. So according to this formula, we write this relative displacement A dash upon perpendicular distance is given by AB. Similarly, this is also relative displacement DD dash. So we write that is equal to DD dash upon DC. If you consider only this front side, then we get this, and that is equal to shearing strain. Now if we consider this triangle A dash B, it is right angle triangle. In this case tan theta is equal to A dash upon AB. Similarly, if you consider another triangle DD dash C, in that case relative displacement of this layer is D dash upon perpendicular distance is DC, or tan theta is equal to DD dash upon DC. So according to this, we can write shearing strain is equal to tan theta from this figure. If this theta is very small, then tan theta is nearly equal to theta, and then shearing strain will become theta. So in this way we study about the strain and its type: shearing strain, volume strain and tensile strain. As like strain, there are also three types of stress: tensile stress, volume stress and shearing stress. Now depending upon this stress and strain, for elastic body, this stress depends upon strain, and that law is called as Hooke's law. So we have to study the Hooke's law. This Hooke's law gives us relation between stress and strain in case of elastic bodies. So according to Hooke's law, within elastic limit, stress is directly proportional to strain. This law is called as Hooke's law. Within elastic limit, stress is directly proportional to strain. This is the statement of Hooke's law. So we write, according to this law, we can say that this stress is directly proportional to strain, and therefore stress is equal to some constant into strain, and therefore this stress upon strain, that is equal to constant. Stress upon strain, that is equal to constant. These constants are called as elastic constant. These constants are called as elastic constant. Now we have to study about the elastic limit. What is elastic limit? So this elastic limit is the maximum value of stress. It is the maximum value of stress up to which stress is directly proportional to strain. So what is elastic limit? So elastic limit is maximum value of stress up to which stress is directly proportional to strain in elastic region. Here we consider only elastic region, and in this elastic region, this maximum value of stress up to which stress is directly proportional to strain is called as elastic limit. Now this constant is called as modulus of elasticity. This constant is also called as modulus of elasticity. And also this called as elastic constant. So with the help of this formula, we can define the definition of modulus of elasticity. Modulus of elasticity is defined as simply ratio of stress to strain. So with the help of this formula, we can define the modulus of elasticity. This modulus of elasticity is defined as ratio of stress to strain. Simply ratio of stress to strain is called as modulus of elasticity. According to this definition, we can plot a graph of stress against strain. Means strain is along the x-axis, stress is along the y-axis. The nature of graph is straight line passing through the origin, which shows that as stress increases, strain also increases, and therefore nature of graph is straight line passing through the origin. Now slope of this graph gives us modulus of elasticity. Also this slope of this graph gives us modulus of elasticity. So another definition of modulus of elasticity is defined as slope of stress strain curve in elastic region. That is called as modulus of elasticity. In this way we study two definitions of modulus of elasticity. Modulus of elasticity is simply ratio of stress to strain. Now according to this graph, we can say that modulus of elasticity is slope of stress strain curve in elastic region. This is about the modulus of elasticity. Now we stop here. Thank you.